Hi all. Today's topic is signal flow graph. Again, signal flow graph is used to find the overall transfer function of a control system, similar to block diagram. Block diagram is also used to find the overall transfer function. It is the pictorial representation of the of a control system. Similarly, signal flow graph is used to find the overall transfer function of a system, and it is a graphical representation of algebraic equations. Basic elements are nodes and branches. Basic elements of a signal flow graph are nodes and branches. And what is a node? Node is a point which represents either a variable or a signal. There are three types of nodes, that is input node, output node and mixed node. And what is input node? It is a node which has only outgoing branches. Input node means it is a node which has only outgoing branches. Similarly, output node, it is a node which has only incoming branches. Mixed node means it is a node which has both incoming and outgoing branches. So, see this figure here. Y1 is the input node which has only outgoing branch. Y4 is the output node. It has got incoming branch. And Y2 and Y3, they are mixed nodes because they have both incoming and outgoing branches. Y2 and Y3, incoming and outgoing branches are there. Therefore, Y2 and Y3 are mixed node. This is input node, this is output node. And what is a branch? Branch is a line segment which joins two nodes. It is the directed line segment. So, this is a branch, directed line segment. It has both gain and direction. So here this is one branch, this is another branch, this is another branch, this is thus there are four branches are there. And gains are, for this branch the gain is A, for this branch the gain is B, for this branch the gain is C, and for this branch the gain is minus D. Now what is a path? It is the traversal of connected branches in the direction of branch arrows such that no node is traversed more than once. We have to travel along the direction of branch arrows. So here it is traversal of connected branches in the direction of branch arrows, and condition is no node is traversed more than once. Example y2, some examples y2, y3, y4, y5 along the direction of branch arrows. y5, y3, y2 again. This is another path. So many paths are there in this case. This y2, y3, y5, y6 another path. The condition is no node is traversed more than once. So y1, y2, y3, y4, y5, again y3, y2. It is not a path. That means y1, y2, y3, y4, y5. It is a path. Then again y3 second time. So it is not a path. No node is traversed more than once. It is the traversal of connected branches in the direction of branch arrows such that no node is traversed more than once. So remember this condition. No node is traversed more than once. Remember that condition. Then forward path. It is the path that exists from the input node to the output node. So in this example, in this diagram, y1, this is the input node, this is the output node. So y1, y2, y3, y4, y5, y6, it is a forward path. And in this particular diagram, there is one more forward path is there, that is y1, y2, y3 along this path, along this branch, y5, y6, y1, y2, y3, y1, y2, y3, y5, y6. So one forward path is this y1, y2, y3, y4, y5, y6. Another one is y1, y2, y3, y5 along this branch, y5, y6. And what is forward path gain? It is obtained by calculating the product of all branch gains of the forward path. So first forward path, we take this as the first forward path, no matter. So gain is product of all the gains. So A, B, C, D, E is the forward path gain of this first forward path. Second forward path is this, that is its gain is A, B, G, E. A, B, G, E. A, B, G, E. So that is the forward path gain. Now, what is a loop? The path that starts from one node and ends at the same node is known as a loop. That means it is a path which originates and terminates at the same node. It is known as a loop. So see this figure, y2, y3, y2. It is a loop. Similarly, y4, y5, y4. It is a loop. Then y3, y5, y3, another loop. y3, y4, y5, y3, another loop. Let's see, these are some examples for loop. But in this figure, y3, y5, y4, y3, it is not a loop because the direction loop is, it is the path that starts from one node and ends at the same node. It is known as loop. So the path, and what is path? It is the traversal of connected branches in the direction of branch arrows, such that again no node is traversed more than once. So here the direction is changing. So this is not a loop. Y3, y5, y4, y3. It is not a loop. But y3, y5, y3. It is a loop. y4, y5, y4. It is a loop. y3, y4, y5, y3. It is a loop. This is also a loop. So that is about loop. Then what is loop gain? It is obtained by calculating the product of all branch gains of a loop. So consider this loop y2, y3, y2. This is a loop. Its loop gain is B into J, product of all branch gains. Similarly, y3, y3, y5, y3. The loop gain is G and H. For this particular loop, it is E. For this loop, it is D into I, etc. Now, last one, non-touching loops. What is non-touching loops? Loops are said to be non-touching loops if they do not possess any common node. If they do not possess any common node. So here y2, y3, y2 and y4, y5, y4. These two loops have no common node. So these two loops are non-touching loops. y2, y3, y2 and y4, y5, y4. These two loops are non-touching loops. But this loop and this loop, it has got a common node y3. So it is not non-touching loops. Okay. Now, construction of signal flow graph. Consider some algebraic equations. y2 is equal to a1 to y1 plus a4 to y4. Similarly, consider these equations. If we are considering these 5 equations, there will be 6 nodes, that is y1 to y6, and 8 branches. 1, 2, 3, 4, 5, 6, 7, 8 branches are there, and gains a1 to a4 to etc. gains. In order to get the overall signal flow graph, what we have to do is first we have to mark all the nodes. First, mark all the nodes, that is variables y1, y2, y3, y4, y5 up to say y6. Then take the first equation. Y2 is equal to a1 to y1. Y2 is equal to a1 to y1. So y2 is equal to a1 to. Remember the definition for transfer function. Again, this is individual transfer function. So this a12 is equal to y2 by y1. Okay, so y2 is equal to y1 into a12. That is first expression. Similarly, y4, y2 is also plus y2. That is a42. So from this direction, arrow will be in this direction, a42. It is not 2 4. So a42, so it will be in this direction. Then second equation, so that is y2. Second equation, y3 is equal to a23 y2 plus a53 y5. Y2 and y3, that is a23. Here it is a23. A53. A53. So loop. A53. y5, y3. Similarly, y4 is equal to a34, y3. So connect that, a34, y3. Then y5 is equal to a45 and a35. So parallel, a35. And last one, y6 is equal to a56. So y5, so y6 is equal to, this is the gain. Here the gain is a56. Now combine. So this will be the signal flow graph of the overall system. Combine all this. So you will get this. This is the signal flow graph for this particular system, having these algebraic equations. Just look at the equations and connect all the nodes according to the equation. First mark all the nodes, then connect all the branches using these gains. In the next class, we can study the Mason's gain formula, which is used to find the overall transfer function of a system. Thank you.